Okay guys, so continuing with 2.6, we're going to talk about the composition of functions. And so it tells us here in that first slide there on page 4 that the composition of the function f with g is denoted as f, and you notice it has a little open circle. That's the meaning composition of, so f composed with g, and is defined by the equation, and so they write it as f composed of g with respect to x. But guys, that's the same thing as saying f of g of x. And we've seen this notation before because we found things like f of 4 when you were given an equation. And so let's actually do one of those before we move on to the next step. So if I told you that f of x was equal to x squared plus x minus 7, and I want you to find f of 4, we know that all we're going to do is plug 4 in for x. So we would do our skeleton, and we're going to plug 4 in everywhere that there's an x, and then we simplify it. We're putting a number into the equation, so we should get a number out of the equation then. So we would have done 4 squared, and then we just have plus 4, and we have minus 7. And then I'm just going to work this out this way. So 16 plus 4 is 20 minus 7, and we would find our answer was 13. Alright, so we do f of g of x the same way. The only difference is I'm not just going to be plugging in a 4, I'm going to plug whatever g of x is into that equation. Alright, so we're going to do that in just a minute. And then on that same slide it talks about the domain. The big thing there is the domain of the composition here. You see number 1, it says that x is in the domain of g. What that means there is x is in the domain of the input, and number 2 says g of x is the domain of f, meaning that, number 1 means that the domain of the input, let me do it like this. So that's going to be our g of x because that's what we're plugging in. And number 2 says it's going to be in the domain of the output. So the domain for the function has to be in the domain of both. So this is where I would graph them, and the domain would be the overlap. And we're going to do some of that, so don't worry if you're still a little confused on it. Alright, so let's look at example 3. Example 3 tells us that if we're given that f of x is equal to 5x plus 6, and g of x is equal to 2x squared minus x minus 1, find f composed of g of x. So remember that f composed of g of x just means we're going to find f of g of x. So we're going to take this g of x and we're going to plug it into our f function. So I'm going to take and figure out what g of x is. So I'm going to have f of, well, what is g of x? Well, we can look up here, and g of x is 2x squared minus x minus 1. So let's put that there. Alright, now that we know that, remember, it's just like this is in the place of that 4 that I looked at just a minute ago, and we're going to plug that into the f function. So f is my skeleton, and it was 5x plus 6, and we're going to plug what I circled there in blue in for our x. So we have 2x squared minus x minus 1, and then just like what we did when I did that f of 4, we're just going to simplify that. So let's take this 5 and distribute it. So 5 times 2x squared, and then 5 times, be careful, that's a negative x. And then 5 times, that's a negative 1. And then bring down your plus 6. And can we simplify that any further? Well, we got like terms right here, so we need to combine them. So bring down your 10x squared minus 5x. And then negative 5 plus 6 is a positive 1. Can't simplify it any further, so there is our solution.